Welcome back, class. Thank you for joining me for 6-6. Today we're going to dive into a brand new section. We're branching out from just dealing with radicals. We're going to be dealing with what are called function operations. All right, and function operations, what we're focusing on today is being able to add, subtract, multiply, and divide fractions. So this little table here gives you a little snippet of what we're talking about. Now, most of this is going to be common sense. Most of this is going to make total sense to you, but it's something that's a good review to lead into tomorrow. So basically, a lot of what today is going to be is notation. So what I need you to understand is if I write something like this, f plus g of x is the same thing as just adding the two functions together. Same thing with subtraction. If I say f minus g of x, really all you're doing is subtracting the two functions. That's really the main thing of today is getting the notation and being familiar with these adding, subtracting, multiplication, and division steps because tomorrow we're going to start something new, a new function operation. So moving right in. What we want to do, we want to add these two functions together and then state their domains. So if I'm taking f of x plus g of x, that's going to be 4x plus 7 plus square root of x plus x. So if I'm adding these two functions together, really all I'm doing at this point is combining like terms. So like terms, well, let's see here. I see a 4x and a 1x. So 4x plus 1x is 5x. I see a 7 here, but there's no other constants. And then I see a square root of x, and I don't see any other square roots, so it's not going to be able to combine with anything else. Now here, when there's a square root in there, I'm not too particularly picky about the order that you write those in. That answer for me will be just fine. You can leave it just like that. The big thing you need to make sure you do is combine any like terms, and if it's a polynomial, then I'd like you to write it in the standard form. But if not, if it's something like this, just do the best you can. Now, in terms of the domain, so when we're looking at the domain of this, now polynomials we know have no domain restriction. Polynomials such as lines, quadratics, cubics. When we're talking about those, you guys have already experienced that there is no domain restriction, okay? We're talking about all real numbers. However, we have a little piece here. We have that square root of x. That is going to give us a domain restriction because we know that we can only take the square root of 0 and positive numbers. You cannot square root negative numbers. So it's going to give us a domain restriction that our x's have to be greater than 0. That's the only way we can graph this and analyze this function. All right, looking at our next one. So now we're going to subtract our two functions. We're going to have f of x minus g of x. Now, again, be very careful here. I remember when we were doing this back in chapter 1, I taught you a little technique. I want you to distribute that negative in to make it more obvious. So that's going to be a minus square root of x and a minus x. So again, make sure that when you are subtracting, distribute that negative in so you don't have to deal with trying to remember, oh, I'm adding a negative or I'm subtracting a negative, all that stuff. So now we have 4x minus 1x. That's going to leave me with 3x. We still have that plus 7 and a minus square root of x. All right, and just like I said before, the final thing is domain. And again, we have that same issue. We still have a square root of x in there. So we still have to make sure that we're not square rooting a negative number. So we have to make sure that we're only using x's greater than or equal to 0. All right. So let's do another example of adding and subtracting. Now, you can see here, I've transitioned to using that other notation, f plus g of x and f minus g of x. But again, it means exactly the same thing. So I have f plus g. So f of x plus g of x. When we're adding and subtracting, really all we're looking to do is combine like terms. So this 2x squared, looking at that, it doesn't have a like term. So I'm not going to combine it with anything. This x doesn't have a like term. So I'm not going to combine it with anything. I have 8 and a minus 3. Those are like terms. So those I'm going to combine to give me a positive 5. And now that I've combined my like terms, now that is the end. Now, in terms of stating the domain. So I told you in the first example, so all we have to do is reemphasize it here. Whenever you're dealing with a true polynomial, okay, so this is a quadratic. True polynomials are going to be all real numbers. There's no domain restrictions for these. All right, looking at the next one, f minus g of x. So really this is saying f of x minus g of x. So we're going to have f, then minus g of x. And remember, when you're subtracting, the first thing I want you to do is I want you to distribute that negative so you remember it. So we're going to have 2x squared plus 8, like normally, then minus x and a plus 3. And again, it can be more difficult to see if you don't do that distribution. There are a lot of sign errors, so please make sure that you do it this way. So look at that 2x squared. Well, it doesn't have any like terms, so I'm just going to rewrite it. I have my minus x, no like terms, so I'm just going to rewrite it. Then 8 plus 3. 8 plus 3 gives us 11. So now that all of our like terms are combined, now it's time to think about the domain. But in this case, again, the domain isn't that interesting because it's a polynomial. The domain is just going to be all real numbers. All right, so before I move on, please make sure you have all this written down, even if that means you need to pause this video first, because we're going to move on to multiplication and division. So multiplication and division, it's going to be the same idea, okay? So f of x times g of x. Well, I'm just going to write that. F of x times g of x is going to look like that. Well, now here, instead of just simply combining like terms, if you notice, I have two binomials multiplying each other. This should be screaming foiling to you. So x squared times x is x cubed. X squared times 3 is 3x squared. Negative 9 times x is a minus 9x. Negative 9 times 3 is a negative 27. And so once you FOIL it out, you'll actually see that that's the end of your problem. It's already finished because there are no like terms to combine. It's already in standard form. So you're actually already good to go. In terms of the domain, well, if you notice, it turned out to be just a really nice polynomial. So the domain is going to be all real numbers. You can use any x for any polynomial. All right, now let's look at f of x divided by g of x. Here is actually going to start getting a little bit more interesting. So f of x divided by g of x. So we're going to have x squared minus 9 divided by x plus 3. All right, so now this is where it's actually going to get a little bit more interesting. I want you to notice x squared minus 9. That should seem familiar to you, okay? That's one of those special factoring methods. Now, you might shudder at the idea that I just brought up the word factoring. However, if you remember back from Expo, when you're looking at rational things, when you're looking at polynomials being divided, the first thing you always have to do, you have to check to see if they factor. This factors as a difference of squares. It's that special factoring case. All right, so yes, in some of these you are going to have to remember your factoring methods because when you're dividing, factoring is the only way to simplify. Because once I do this, now I can see, oh, I have an x plus 3 on top, x plus 3 on the bottom. So that's going to simplify to x minus 3. However, there is one little thing. So the domain, I said this is going to start getting a little bit more interesting. And here is where that happens. So when you're dealing with rational things, again, this should be a really nice review from exponential algebra, but we have a concern, all right? We can't let ourselves divide by 0. However, we're dividing by something unknown. We're dividing by x plus 3. So we have a little problem here because we don't want to allow ourselves to divide by negative or divide by 0. So we're going to allow ourselves to use all real numbers except we don't want to divide by 0. So we have to exclude when x is negative 3, because picture plugging a negative 3 in there. If x were negative 3, that would make you divide by 0. So we have to put a domain restriction on here. We can say that we are going to allow all real numbers except x can't be negative 3, because if it were, in the original problem, we would have been dividing by 0. It doesn't matter that that piece cancels off. What matters is that it started that way. All right, one last example. So first, f of x, so 3x squared minus 11x minus 4 times g of x. Well, now we can't technically use foiling here, but foiling is what you should be thinking of. But remember, well, what we end up doing is just sending everything from this first parenthesis into everything from that second parenthesis. So I send the 3x squared to the 3x to get 9x cubed, and I send it to that plus 1. I send the 11x to the 3x to get negative 33x squared, and I send it to the plus 1. Take the negative 4, same thing, I send it to the 3x to get a minus 12x, and I send it to the 1. So it's like foiling. You're just sending everything from the first parenthesis into both things of the second parenthesis. So you end up getting 6 terms, and now that's going to leave me a lot to combine. So 3x squared minus 33x squared will give a minus 30x squared. Negative 11x minus 12x will give us a minus 23x. Then we have our minus 4. So again, like foiling, but it's that slightly longer one that we're going to have to do. And now I have it written in standard form, and all like terms are combined. So my domain, well, is just a normal polynomial. So it's going to be all, all real numbers. All right. Now, the one where it's going to get a little bit more interesting. So f of x divided by g of x. So that 3x squared minus 11x minus 4 divided by g of x. 3x plus 1. And again, with division, if you remember from Expo, the biggest thing is factoring. So the top actually does factor. You get 3x plus 1, and you get x minus 4. Now, remember, if you're struggling in getting this, recall, I got the 3x and the x because that multiplies to 3x squared. I got the 1 and negative 4 because that multiplies to negative 4. And then if I'm checking my connections, here I get a 1x minus 12x, and that gives me that negative 11x in the middle. Now, if you need a little refresher on that, please see me during class, or you can reference your chapter 4 notes. That goes all the way back to chapter 4 that we were doing that. All right, and now the cool thing is, now that we've done that, we can cancel what's the same on the top and bottom, and we're left with x minus 4. All right, and last thing, the domain. So remember, these are going to be all real numbers also, except, so we need to find what x can't be. So again, we can't divide by 0. So we have to make sure that that does not equal 0. Now in the first case, it was really easy to see that that putting in a negative 3 worked. For these slightly more complicated ones, you can actually set this up. 3x plus 1, we don't want to let equal 0. Subtract the 1 over, and then divide by the 3. So if you ever struggle seeing it, you can write out a little equation. Set the denominator not equal to 0, and then solve like you would any normal linear equation. And you'll get that x cannot be negative 1/3. Because if it were, in the original problem, we would be dividing by 0, and that is not allowed. All right, so thank you for joining me. Please make sure that you have all this written down, and then come back to class ready to do our practice work.